The subject refrigeration and air conditioning is related with students of aeronautical engineering, although other branches of engineering may also take use of it. It is divided into 8 different parts. This is the first part, which is related with the introduction and applications of refrigeration and air conditioning, types of refrigeration, different parameters, applications. So let us start with the brief history. So before going into the detail of history, two basic terminology is required. First is what is refrigeration and the two different type of heats associated with it. One is latent heat, other one is sensible heat. So refrigeration is the process of removal of heat from a material, and generally it is from a space, to control the temperature, and it shall be lower than the surrounding temperature. So when a refrigerant absorbs unwanted heat or additional heat, it raises the refrigerant temperature, which is known as saturation temperature. When saturation temperature occurs, the changes from liquid to gas, means from one phase to another phase, occur. So it is a type of absorption. Then once absorption completed, the condensation starts. So during the condensation process, the heat is released and refrigerant is back into the liquid phase. So that released heat is known as latent heat. So it is basically carried out in different cycles. Once all the cycles combined, it will give you the overall process, which is known as refrigeration, or you can say it's air conditioning process. When it is done through a closed loop pipe system and contamination and other controls, it will be known as refrigeration system. So saturation temperature is the important factor here, which is related with the definition of temperature, which is related with the change of phase. It may be vapor, it may be solid also, where the heat is removed. So saturation temperature is generally related with the parametric definition of temperature with the removal and addition of heat. So whenever heat is removed or added, a change of state transfers to a large amount of energy. That energy can be used into different type of works, like water, which is an example of saturation property of a material, can transfer a large amount of heat. Similarly, refrigerant and other principles such as ice, it has some different type of saturation temperature values. So the important understanding is that if the pressure is low, the saturation temperature is low. If the pressure is high, so the saturation temperature is also high. Now latent heat is the heat required to change a liquid to a gas without change in temperature. It is known as latent heat. Heat is the form of energy where it can be transferred from one object to another object, and also create a temperature difference. The heat transfer which can occur during the temperature difference related with the one or two or maybe more objects also. As general principle, heat will flow from warm object to colder object. So when heat transfer is greatest when there is a large temperature difference between these two objects. So all these basic concepts of sensible and latent heat related with the heat transfer. Therefore, when a student adopt this course of refrigeration air conditioning, he needs to be familiar with the few fundamental principles of thermodynamics, fluid mechanics and heat transfer. In the history of refrigeration and air conditioning, it was started way back in 19 or you can say 1824, where a liquefied ammonia is used as a refrigerant to create the ice. So uh, initially it was started with the preservation of food, so that food can be preserved for a longer duration, and it was felt that the preservation of food is required to avoid the growth of bacteria, so that you can have longer shelf life of a fruit. The commercially available air conditioner, it started in 1902 with the Carrier Air Conditioning Corporation, where they have started the air conditioning for a personal comfort, and the commercial production was started. The person Carrier, Willis H. Carrier, is known as the father of modern air conditioning. Carrier invented different type of processes with the use of freon in 1928. Also, different type of CFC and HCFC, chlorofluorocarbon and hydrochlorofluorocarbon refrigerants, are used during these development of refrigerants and refrigeration system subsequently. Although the CFC and HCFC refrigerants are causing the depletion of ozone layer in our atmosphere, that is causing harmful rays to penetrate our earth. The refrigerants such as R11, R12 and R22 are the refrigerants which can be used instead of CFCs. Although non-ozone depletion refrigerants such as R410, these are natural refrigerants basically, are recently used in the air conditioning systems. The Carrier Air Conditioning Company was based on America. So 1820, 1824 and so on. So different scientists create different type of concepts, and simultaneous development into different concepts is used to modernize the air conditioning as well as the refrigeration system. The commercially available technology are sold worldwide from 1953 to 1997. The development of heat pump in 1977 allows cooling and heating cycle simultaneously in the same machine, so that the cost effective solution of refrigeration air conditioning can be used during summer as well as winter season. But due to the development of nature hazards to the natural environment, environmental condition around earth, two important protocols were signed. One is known as Montreal Protocol, another one is Kyoto Protocol. So Kyoto Protocol is related with the protect of earth climate by reducing greenhouse gases that causes climate change, and Montreal Protocol is related with the protect of earth ozone layer. And on all these protocol, it was decided that with a gap of 15 to 20 years, some harmful refrigerants will be phased out and alternate refrigerants will be used. Now, why we need a refrigeration air conditioning? Generally, air conditioning and refrigeration are required to provide a thermal environment around any space. Generally, all commercial office buildings, aircrafts and industrial plants require air conditioning, so that whatever product or maybe human being also feel comfortable and has maximum efficiency of working. So air conditioning is generally known as the process of treating and distributing air in controlled temperature with a control parameter of humidity, concentration and air quality. So there are two terms, one is refrigeration, other one is air conditioning. So what is the difference between these two? So air conditioning is the conditioning of a particular space, while refrigeration is the lowering the temperature from the atmospheric temperature. So the air conditioning may be like we can control the temperature above the atmospheric temperature, but in refrigeration it is always lower than the atmospheric temperature. This is the basic difference between refrigeration and air conditioning. In refrigeration system, there are two type of system which is generally used. One is compressor based refrigeration system, other one is absorption based refrigeration system. In compressor based refrigeration system, we need to use one refrigerant which can be converted into different phases from from liquid to vapor and vapor to liquid phase. While in absorption based refrigeration system, brines or different type of solution of antifreeze solution may be used. So these are the two popular methods of producing cooling. One is direct method, where water sprays are used to remove dust and odors. Many methods other than water spray. It is the distribution of chilled air in central and air conditioning system. Also in water refrigeration system, air washers, open recirculating cooling system, chilled water system, and other types of system can be used in industrial air conditioning and refrigeration systems. So the basic mechanical component of air conditioning system is the air and water distribution system and a refrigerating machine, apart from a heat rejection system. So generally a compressor based refrigeration system is used with two heat exchangers, one heat rejection system and one heat absorption system. And in the compression refrigeration system, it is also used as halocarbon compound and ammonia as a refrigerant. Internal combustion engine, turbine, electric motor supplies the power to the drive to drive a centrifugal air positive displacement compressor. Refrigeration and you can say cooling occurs when the liquid refrigerant absorbs heat by evaporation, generally at low temperature and pressure. When the refrigerant condenses, it releases heat to any available cooling medium. Generally the medium is considered as air. Water is not preferably considered as a cooling medium. So once the method of refrigeration is decided, the measurement parameters are also required. So first is the requirement. The requirement of available space is decided based on the capacity of refrigerating plant, which is defined as the ton of refrigeration. So in general air conditioning, if we go to the market, we'll ask this much size this needs to be air conditioning and refrigerated. So what would be the capacity of the refrigeration system? So the supplier, they will ask you what kind of area, how much length, and etc. Based on that we can provide our dimensions, then the supplier or the manufacturer will give you the capacity of the machine. So the general capacity is defined based on the ton of refrigeration. So what is the ton of refrigeration? It is the most important unit of a refrigeration system. So 1 ton of refrigeration is the amount of cooling obtained by melting 1 ton of ice in 24 hours. In kilowatt it is 3.5 kilowatt. Other British thermal units and kilocalorie per hour are also mentioned here. Apart from that, the performance of a reference system is measured based on its coefficient of performance, because in thermodynamics we have a refrigerator and heat pump. So both refrigerator and heat pump are basically measured based on coefficient of its performance. So similar coefficient of performance can be defined as a criteria for defining the efficiency of this particular system. Kilowatt per ton of rating is also a criteria. Other than that, one EER ratio is also mentioned on the refrigerator air conditioning system, which is the measurement of performance of smaller chillers or rooftop units, which is measured in EER ratio, which is energy efficiency ratio. So it is calculated by dividing a cooling capacity by its power input. So higher the, these are the expression for coefficient of performance, refrigerating effect by input, energy efficiency ratio, also refrigerant effect by input, which is in watt, is power consumption. Power per ton is also input by the refrigerator effect. The important expression is the net refrigerating capacity, this one, which is mcp delta T. So m is the mass flow rate of chilled water if it is a water chilling plant. Cp is the specific heat at constant pressure, and the temperature difference, which is the chilled water temperature at evaporator inlet and evaporator outlet. So these are the different type and general applications of refrigerator air conditioning system. Split air conditioning, fan based air conditioning, air handling unit, larger system, evaporating cooling, these are the few air conditioning system. And similarly for refrigerator system also, comfort air conditioning, chilled water system, brine systems, and other two principally refrigeration plant that we have already discussed, like compression and absorption based refrigeration plants. So this is the introduction is now completed. The next would be the different type of refrigerants.